Hello everyone. Today we're going to learn how to deploy a multi-module endpoint with multiple trained machine learning models to a single real-time inference using Amazon SageMaker notebook instance. We are going to go about what exactly is SageMaker, what is a multi-module model, and how to do the setup. But before we get started, please like, subscribe, and share the channel, and drop in a comment if any questions. So without further ado, let's get started. In this tutorial, we'll cover how to deploy multi-model to a single real-time inference endpoint using SageMaker. We are going to focus on multi-model deployment to simplify management and reduce cost. Spin a SageMaker notebook instance for orchestration and deployment. What is SageMaker Studio? SageMaker Studio is an fully managed IDE for machine learning with Jupyter notebooks. It is an integrated development environment for machine learning that provides a fully managed Jupyter notebook interface in which you can perform end-to-end ML lifecycle tasks, including model deployment, data prep, training, tuning, and deployment. This is ideal for developers and data scientists who are working on AWS. SageMaker, it offers different inference endpoints to support a broad range of use cases, like SageMaker real-time inference, serverless inference, asynchronous inference, and batch transform. What is a multi-model endpoint? It hosts multiple models on a single endpoint. Dynamically loads models from Amazon S3 on demand, ideal for many use cases with small models, example, personalized models per region models. And in this tutorial, we are going to be using the SageMaker real-time inference option to deploy a set of binary classification XGBoost models that have already been trained on synthetic house price prediction dataset. The dataset consists of details on house prices based on features such as number of bedrooms, square feet, and number of bathrooms. And these models will predict housing prices for a single location. You will play the role of a machine learning engineer to deploy these models and run sample inferences. With this lab, you should be able to learn how to create multiple SageMaker models from respective trained model artifacts, configure and deploy real-time endpoints to serve these models, and invoke the multiple endpoint to run sample prediction data. So let's get started. So we are going to be deploying the models programmatically using a SageMaker Studio notebooks, which requires a SageMaker Studio domain. An AWS account, it can have multiple Studio domains per region. If you already have a SageMaker Studio domain, you could just proceed. If not, you could use this template, and this is the standard AWS template. And I'll give the link in the blog as well that you could use to spin it up. So give the default parameters that are provided. You could leave the name and just leave this setting and hit create stack. Just hit acknowledge. Hit create stack. It will take a few minutes for the resources to be created, and we can hit refresh to check the status of all that it is deploying. We can check the YAML file, which is the CloudFormation. This is the YAML file for CloudFormation that is spreading the resources. As you could see, there are multiple regions here provided and the notebooks that could be used. And this is where you should be creating the studio domain and user profile. So all the regions are mentioned here. The region map is provided, but will be used for region map. In the resources, there will be the Lambda execution role that is going to be created. SageMaker execution role for the S3 access will be required because it will be needing access to S3. The Lambda policy, execution policy, enable profile projects, studio bucket, the S3 bucket that it will be creating, and it will do all this for you. So you could check out this code for yourself. One, what it is doing, it's a simple YAML file, so it should be very easy to read. While the stack is still getting created, just one resource is pending. Let's go and do the other work on SageMaker Studio. So let's come in the search bar, just type SageMaker Studio, open this in a new tab. You have the studio, ensure you have the studio, you have the right region selected. Click create a SageMaker domain, and here just leave the default for your single user setup. But if you use organizations, you should be using this particular option. But for now, I'll just go with the single user setup. It will take some time to set it up, and we can resume once this is created. So now we see our domain is in service. Come back to Studio, click Studio on the left side, and click Open Studio with the user profile selected. Oh. You should see this dashboard being created, and you could do a SageMaker Studio tour if you want. I'll just do skip tour for now. So now with this Sage Studio open, come here to Jupyter Lab because we need to create a notebook. Create Jupyter Lab space. Give a name. I'll just give it YT. I'll do a share with my domain. And hit create space. Let's give it some time to let it run. Okay, so the space is running. Over here, once this is done, we are going to be leaving this default empty medium. For this, I will just use the latest image and do run space. It will take some time, and once it is running, we can resume. Now we need to instantiate the S3 client object and locations inside our S3 bucket where the model artifacts are uploaded. We will copy and paste this code in the cell and run it. Do Shift Enter, and now we need to make a copy of the model artifacts from the public S3 bucket to the session created S3 bucket. For this, we will copy this code and put it at the and move this to the top, and now run. Okay, it is run, so we should be good. And now we will create a real-time inference endpoint. In SageMaker, we can deploy a trained model to a real-time inference endpoint using either the SageMaker SDK, AWS SDK Boto 3, or the console. To deploy the model, we need to do 3 steps. Create a SageMaker model from the model artifact. Create an endpoint configuration to specify properties. And create the endpoint using the endpoint configuration. So first, to create a SageMaker model using the trained model artifact stored in Amazon S3, we are going to copy and paste the following code. Let me run this. So this was the code we will use, and let's try running. Now what we can do is we can check the created model. So now we can come back to this console, and this is where you should see the model created. Once this SageMaker model is created, we can copy and paste the code to use the Boto 3 create endpoint config to configure the endpoint. The main inputs of this are the endpoint configuration name and the variant that we are going to be providing. So let's run this by doing Shift Enter. And this is where it will have it changed. We could check out the created endpoint configuration. We can refresh this. So refresh this. You could see the details here, but there are no endpoints. So let's do one thing. Let's just delete this because apparently the name was already there. And then let's retry. Okay, so there are no models. Let's run it again with the entire code. This is for 3 I've added. Now let's go and create the endpoint. So in here, I paste this code, and all this code is going to be there in the blogs. So where the method takes the endpoint configuration as a parameter and redeploy the model specified in the endpoint configuration to a compute instance. It can take about 6 minutes to deploy the model, but let's run it. If we click into the model, we can see the endpoint status, and it is still being created. We can click on the endpoint name, and we can see there for additional details, the status it is creating, the variants, and after this, once it is done, it should show the status of in service. So it takes a few minutes, so we'll resume once this is in service. So now the endpoint is created and it is in service. We can come and verify the status from here as well, where we could see it is in service. Now, for step, we are going to invoke this inference endpoint over here. For this, we could use any setup with a REST API, AWS SDK, Boto 3, But for this, we are just going to use SageMaker Studio, and I'm going to use this particular code snippet that it is going to be there in the blog as well that you could use. I could add another step cell and I paste this code where I'm saying I need to run the particular endpoint to see the result. I run it, and there you go. The results are coming for the housing setup. Now, once the execution completes, the cell is, we see that returns the model predictions for the test sample done. We can also monitor the endpoint invocation metrics using Amazon CloudWatch. We click this endpoint and we can check these settings, check the logs. It will open a new tab. Check for the endpoint of the response being returned, the data that is there for the model that you have created. And you could also check for the test inference you want. You could send the data from here as well instead of rest. So we saw how to deploy the model and the endpoint using code, but using this portal console as well, with the deployed model, you can come and create the endpoint. You don't need to use code all the time. If you're more comfortable, you could use this endpoint. You can provide the instance type that you want your endpoint to run on. Click the model, choose the deployable models, choose your housing prices, and you could add the model, after which you could hit deploy and it can create your endpoint. I don't need to do this, but this is another way. You can have the endpoint and view the metrics. Now for the last part, we need to clean up all these resources. Otherwise, these are heavy boxes that you see, these extra large machines that are running the models. So it's better to delete so you don't incur unintended charges. To delete the model, endpoint configuration and endpoint you created in this setup, what we'll do, we need to delete the endpoint first. So click here and hit delete. And you can say this is yes, I confirm. Delete endpoint. Deleting endpoint is very important. Because if you do not delete the endpoint, it can very well be that your account will keep accumulating charges for the compute instance running at the endpoint, so do delete it. And once done, come back to your notebook. You click running instances and you stop the Jupyter lab. Now we also had spun up resources in CloudFormation. We can just go ahead and delete this stack. And this is where it will be deleting all the resources, all the S3 buckets created as part of the stack. Okay, so it deleted. It will take a few minutes because it did take a few minutes to create. Deleting as well will take some time. So this is where you could come, click delete space, and it will also delete your space and your notebook as well. So if we come to CloudFormation, it's still deleting. It does take some time, and we can check to ensure the resources are deleted. So this will take some time, but nonetheless, I think we can wrap up the video at this point, because this shows that we are able to call the API and the model API, deploy it, and then also how we can go about deleting all the resources that we had created. Thank you for liking, subscribing, and sharing these videos. And drop in a comment for anything that you want to understand, specifically in cloud. Thank you and have a good day.